it is Raspberry Pi 3 interfacing with soil moisture sensor and buzzer. So regarding to the Raspberry Pi 3 description, the Raspberry Pi 3 with quad-core ARM Cortex A53 processor is described as having 10 times of performance of Raspberry Pi 1. The benchmark shows the Raspberry Pi 3 to be approximately 80% faster than the Raspberry Pi 2 in parallelized tasks. The CPU of the Raspberry Pi is 1.5 GHz and it also supports the 64 and 32-bit quad-core ARM Cortex. The operating systems of Raspberry Pi 3 is FreeBSD, Linux, NetBSD. The power supply of the Raspberry Pi is 5 volts 3 amps for fully power delivered to USB device. The graphics of the Raspberry Pi 3 is Broadcom Video Core VI 500 MHz frequency. The Raspberry Pi has number of versions. The pin diagram of the Raspberry Pi is the Raspberry Pi contains 40 pin description. So among 40 pins we have two 3.3 power supply pins and 5 volts power supply pins. The red color indicates the 5 volts power supply pins and the yellow color indicates the 3.3 power supply pins. So in this Raspberry Pi 3 we have two universal asynchronous transmitter receiver pins inbuilt. The green color indicates the universal asynchronous transmitter receiver pins. Universal asynchronous transmitter receiver is nothing but the one of the type of the serial communication. The orange color indicates the general purpose input output pins. So here the black color indicates the ground pins. So this is the pin description of the Raspberry Pi, the 40 pin description. So coming to the working principle of the soil moisture sensor. The soil moisture sensor uses capacitance to measure dielectric permittivity of the surrounding medium. In soil, dielectric permittivity is a function of the water content. The sensor averages the water content over the entire length of the sensor. So coming to the interfacing, regarding to this interfacing, coming to the software part is nothing but our coding section. The coding section, here it is. Import rpi.gpio as GPIO. It's a header file of the Raspberry Pi general purpose input output pins. Import time is nothing but the delay function of the program. Sensor underscore soil is 40 pin. Here 40 pin is nothing but the general purpose input output pin that is taken from the Raspberry Pi 3. The sensor input pin is connected to the 40 pin. Buzzer equal to 38. 38 pin is the general purpose input output pin in Raspberry Pi. Buzzer is the input pin of the Raspberry Pi. GPIO.set mode. GPIO.board. Here we are activating our board as a general purpose input output pin by using the command GPIO.set mode. Here the GPIO.setup means nothing but the sensor pin. Sensor data pin input is connected to the 40 pin and the general purpose input output pin dot setup buzzer is connected to the output. Here the buzzer is an output pin. Nothing but the buzzer acts as an output. Why? Because it giving alert intimation to the people or else any alerting system. By using the setup command, we use the enabling the particular pin we assign for the either sensors or else modules or whatever the components we interface with the Raspberry Pi 3. GPIO output buzzer false means the statement works as the buzzer is in a off state. Initially the buzzer is in off state. By default, whenever we give the input power supply to the sensor, the default string is soil sensor ready. String is nothing but the sensor is ready to sense. It gives the intimation to us. So coming to, we have two conditions. One is sensing condition and another one is non-sensing condition. For sensing condition, we using a if statement. For non-sensing condition, we use the else statement. So if GPIO dot input sensor underscore soil means here reading the sensor data by the command GPIO dot input. GPIO dot output means here the buzzer sirens the whenever the sensor is sensed. The string is nothing but soil is detected. Whenever the soil is detected, the buzzer is giving detection alert system. Whenever the soil is sensing means soil. Coming to the soil sensor is in dry state means the sensor is in sensing state. When soil is in non-sensing means the soil is the dry condition. So coming to the else statement, GPIO dot IO. The sensor is in non-sensing state. The buzzer is in off state. So print. So here it is the sensing is soil is not detected. So coming to the hardware part. So here it is the interfacing of the soil sensor and the buzzer. So soil sensor we have 3 pins. One is data pin, another is ground pin, and another one is VCC pin. The power supply of the soil sensor is 5 volts and the ground pin is connected to the 6th pin in the Raspberry Pi general purpose input output pins, and data pin is nothing but connected to the 40 pin general purpose input output pin. So here it is, whenever sensor is sensing means the soil is detected and buzzer giving the alert system. Sensor is sensing means the soil is in dry condition. Whenever the sensor is in non-sensing, the soil is in wet condition. At that particular moment, the buzzer never gives the siren to us. It is only gives siren in sensing state only. Whenever the sensor sense means the soil is in dry state means the sensor sense. If it is in wet state, the sensor it is in non-sensing state. So the working principle here the hardware is shown. So now the sensor is sensing. So this is the interfacing of Raspberry Pi with a soil moisture sensor and a buzzer system. Have any doubts regarding to this particular project? Please contact 8868 and one more contact is 8857 For our personal mail ID info.vertulonix@gmail.com and our official website is www.vertulonix.com. So please contact the above numbers and the mail IDs regarding to this project. Have any doubts? Thank you.